you have given. We have so these are the three, and this is the one using Keras efficient net. So the person has built the efficient net unit with using efficient net model. So these are the imports, and after that, the basically from these data sets on the right hand side under this data repack and image statistics, these are the three zip files containing data which are loaded and unzipped. And after that, so basically we are creating the data frame to understand using mass that what percentage of each row in the data frame uh, is having that pneumothorax. And I'll just try to explain this. So these are all the this is the data frame creation start, and then if we see here, if the percentage of the for each row, if the percentage of mask is greater than 0, then the disease is detected. So pneumothorax is detected. So this is the mask, initial mask, and then it will go through the each row and then calculate the mass percentage like this. I couldn't understand this why this 255 is there. So after that, so we have the data frame, mass data frame, which contains the label as 1 or 0. And after that, we are going to get the train data. And so this is something we are going to use train test split to get the training data and the validation data. This is the all train data. This is coming from this particular training folder. And after that, we are going to replace in the train. This is the getting hold of all the masks. So from the train folder, what we are doing, we are replacing dot train with dot mask, and similarly for validation as well. So now the other part starts here. So what we are doing here is uh, we are getting the image name, and we have created this image train in this directory, and we are moving the file from train directory to this particular directory, IM train directory, right? And splitting the whole path. This is the whole path, and we are splitting it using slash. And after this is the -1 means the last slash we are using, and after that the image name, the file name is there. So we are moving the file to this particular location, or the new location, this directory we have just created. So we have all the files here in the IM train. Similarly, we have the mask file in the this particular directory, and similarly validation images and the validation mask. So we have created 4 directories, populated that, and this we have created a class using data generator. So basically, what it will do, it will set some of the initial attributes. So this is the image path, and then train mask path, etc. Size is given as 256, and so here what we are trying to do is preparing a batch randomly from the given folder. So this will be used later on, and so this is the function. So this is we are getting the IDs, and after using this particular IDs, we have the batch of 16. We define the batch size here somewhere, right? Height, width, and batch size. So we are picking the 16 random samples from this for each batch, and then we are using this data generation function to get the x and y values on the given IDs of 16. So this is defined again somewhere down, data generation. This is the method. And after this, this is for the augmentation part. And so again, this is for the train set images with mask. let me go a little bit down. Again, the augmentation. So these are the helper methods for calculating the intersection over union. And this is for dice loss, which is twice into area of overlap divided by the total area. Somewhere here, there must be, yeah, this is the function. This is the formula, I mean. We have calculated it for, various cases. So I couldn't understand that with the smoothing and without the smoothing. And again, there are some, these are callback methods, basically depending on the learning rate and when we should stop the training further. Uh, these are the methods will be called from the model itself while we are creating the U model. So it is defining the U efficient model using the efficient net B4. So this is the initial model, and then we have added some convolutions, and we are trying. This is the left side of the model where we are going down, or we are downsampling, and after that, after downsampling and towards the end, we are going to upsample it again, or which is also called the decoder part. And in this, I'm just going down. This is the last layer. So output layer is, if I mean the activation is sigmoid, it means either 0 or 1. We want to detect whether the pneumothorax is there or not. And this is what the model, this function will return the model. Um, so stochastic weight averaging is something uh, that author found it giving better result. So this is what the training is beginning. So the number of epochs are 42 and batch size is 16. It means each batch will go through 42 iterations of, and so this is again the older method what madam you were saying, that data generator dot fit, and so so they are using it here. So once the model is trained, and we got the history. From the history, we can get the various information about the training. So we can plot the history. History has got a history dictionary from which we can get the various details. Um, this is the prediction part, and yeah, I mean that's it more or less.
Yeah, great job. All of you unmute yourself and clap for Soumya. Good job. And share your screen, and who's the next volunteer?
I will try.
Yeah, sure. Yeah. Share.
1 second. Just a second. Can you see my screen?
Yeah, I'm not able to see your screen.
Now?
Yeah, it's
Showing, right?
Yeah.
Okay. So this particular implementation for the pneumothorax segmentation is based on a research paper for a technique called exception, which is what did I read? Depth-wise separable convolution. So basically, that means that each filter, the filter, unlike in regular convolution, is not done for the depth first. It's done layer by channel by channel. It is done separately and then stacked up, and then after that it is done for the depth. The convolution happens depth wise, and then there is a final result. And so that there's an algorithm that they have provided. So the this particular Kaggle solution has been done based on that. They've also used some numerous libraries which I've never heard of, and there's a lot of image augmentation techniques that they have followed as well. So you can, yeah, as usual, I think whatever initial steps that Soumya said, the same things apply here, wherein the all the files are uh, unzipped, and then the pneumothorax is expressed as the percentage of the mask, and then it's expressed here, and then the the samples are split into training and validation, and one thing is that they have stratified it. Test size is 10% is validation, 90% of it is training, and the stratify is given as mask. So I do believe it is in order to get a representation of each type. I think this is the reason why they have used the stratify. I'm just guessing. So, and after that, they are now taking all the files and putting it into folders for validation, etc. And then you have a data generator, which I believe you said is outdated, right? So, so the image path is determined, whether there are augmentations, whether it will be shuffled, etc. How many channels, etc. will be is sort of defined in this functions in the class. And then, there's an iterator as well. And then there's an epoch, and then you have a lot of instantiations for the data generation. And then there's a library called Albumentations, which is basically an image augmentation library which has various manipulations that you can do. You can shear it a bit, you can distort it, you can compress it, you can skew it, you can skew certain sections, you can increase the contrast, you can increase the brightness, or you can increase the saturation. So you can do all those manipulations and also introduce blur, noises, etc. And so they have instantiated that. And now for the training image data sets, so they have given the images, they have displayed the images where if you can see that wherever there is a red smear here, it is actually a symptom of pneumothorax. So they are showing that. And they have applied the augmentations which we saw earlier. So they have applied some of the augmentations, and they're showing the images. Personally, I don't see any big difference, but yeah. So, and then they are calculating the intersection over union, and then of course the dice loss, as Soumya had also mentioned. And then the learning rate here, they have used cosine annealing. Annealing, I believe, is after the metallurgy, where there is a very quick um, way that it will converge after a certain point. So they have used some lot of techniques in terms of the learning rates itself. More than the library itself. What I understood was that they are using a lot of um, image augmentation techniques, as well as determining the learning rate. Earlier, whatever we have seen so far is just we mentioned, I think, saying optimizer is equal to so and so, right? Like I haven't seen um, uh, a learning rate scheduler being assigned like this. This is the first time I'm seeing. So uh, and then this is the model block, which we saw is based on how we had seen in the paper. So, and so this is what we have seen, the middle, the entry flow, middle flow, and the exit flow. So that is what we see here exactly being written out. Apparently, there is a very small amount of improvement in the accuracy for the exception model. And because it is depth-wise, there's a lesser number of parameters used, which means that there will be lesser chances of overfitting. And one more that they are using is stochastic averaging. Uh, Again, there is a lot of, as I said, there is a lot of techniques that they are using to measure as well as to sort of schedule the learning rate. So this is a stochastic averaging, which I believe is basically changing the weights as per the earlier weights with some format. And this is the compiling of the model, and then they are training it, and it converges quite fast. Actually, it didn't take a lot of epochs. So just a second. Yeah. So you can see that the losses started stabilizing and not making any difference after a certain point. And the validation data set, which we had taken the 10%, which we had kept aside, so that is also validated. And there is some images from the validation dataset that they are trying to make a prediction. So where there is an actual disease and that we had predicted it is successful, so it shows in green. And where we haven't sort of completely predicted, those remaining areas show red, which means there is still some fair amount of samples where there is red that you can see. So it's not 100% obviously accurate. And then they are showing, I mean, this section, honestly, I did not understand. Again, they are doing some manipulations, and so they are showing what is the best threshold, where you're getting ideal results. And this is finally the results. They are showing some of the results, and then this is for the training. And then the test data, they are once again trying and checking the test predictions. And there you go. They are, yeah, and they have written it to a CSV. That's it. This.
Yeah, great job, Shivpriya. All of you unmute yourself and clap. Unmute, clap nicely.
Thank you.
Good job. Who's the next volunteer? Good job. Both of you did an excellent job explaining, I think, going to the research paper, explaining all that is very, very good. Surpassed my expectations, both of you. And who are the next three volunteers? Third person. I think after two people have gone through the use case, it should be easy. Who's the next person? How many people are there in the class at the moment? Can you raise your hands? Yeah, 8 people are there. So why volunteers are not coming up? You're not explaining every line of code, just the overview flow. You're able to understand slowly, you will get it. Give it a try, otherwise you will not be able to do it. Well, if you try, you will understand where you're lagging and all that.
Okay, ma'am. I'll try.
Yeah, sure. Good, Gaurav. Share your screen.
Give me 1 minute. I think my screen.
Yeah, sure. Take your time.
Okay. Uh, the objective of this problem is we have to detect the pneumothorax in the images, and for that we are using the pre-trained model, that is unit exception cap, and we are loading the data sets, which is in the form of zip format, and we are getting the mask images and the train and test images. And over here we are getting the mask images in the percentage form. I didn't check what is the form. This percentage may be the uh, that I think pixels values, or else that the image coordinates. So we are converting that percentage value for in the mask images will be greater than 0. So we are converting into 1, so that this problem will be converting into binary problem as a binary. This mask underscore df labels equal to 0 means there is no pneumothorax in the images, and if it is 1, then there is the presence of pneumothorax. This is the uh, number of train files and validation files we are checking out, and this is the data generator. As you said, this is not the compulsory. Okay, now we are using the augmentations library. This is for the augmentation, and augmentation is required for the image in deep learning. We need more images, means more data, that the quantity of the data set will be large, so that we can prevent the overfitting part. And this augmentation helps us to for the augmentation all the images and all. And the augmentations means augmentation means this image we are creating more images, like we are converting original image into horizontal using the horizontal flip, crop, median blur, contrast, and hue saturation in gamma. We are getting 6 images from one image. And then these are the images, these are the mask images without the augmentation, and these are the after augmentation. If you will compare, if you will see, the pneumothorax in this image is this side, and over here is the opposite side. This is augmented image. This is the IOU, which is intersection over union. This is the metric for the evolution. And the formula for the IOU is the true positive divided by true positive plus false positive plus false negative over. But I'm confused if you will go through the code, there is something different. I need to run this code so that I can get the idea what is happening over here, because they are subtracting the intersection part, and the subtracting value they are getting into t into p.
So there is one more formula for intersection over union divided by, there is one more formula for IOU. That formula they have implemented it. Intersection divided by union is the formula. So they are calculating the intersection first between the truth and the predicted values, and then the union between truth and the predicted values, dividing the intersection by union. That is one formula for one interpretation of IOU.
Okay.
So that interpretation they have implemented here.
Yeah, I thought something is happening over here, because the true value and predictive value they are summing up this in numpy array of this
Yeah,
thing. So,
sure. Yeah, go ahead, go ahead.
and they are using the dice loss. Dice loss. Yeah. Okay, dice loss. This is the one kind of loss, and in this, this is the formula for the dice to into a underscore a intersection b and mod of a plus mod of b. In this, what is happening? This is the prediction target. So suppose this is the a and this is the b. This is the target, and we are simplifying in this, and we are taking the sum. And this is the explanation how we are getting the dice value for one image. And now this learning rate scheduler maybe Shall I explain the one what is learning rate schedule, because everything
Yeah, please go ahead. Please go ahead.
uh, actually what is happening in the deep learning models, when we try to find out the weights, we need to decrease we need to decrease the weights and all, and we need to find out the what should be the weight for the decrement. Just suppose this is the graph, and we have to find out the this is one minimum. We have to find out where the loss is very minimum. So we start with the weights, and the weight we are trying to find out the values of the weights where loss is minimum, but by which rate we have to decrease our weight, so that we define that value through the learning rate. So this is the learning rate we are defining over here. This is the model block, this convolution block and residual block. In unit, the concept of unit model is like we are downsampling the images using the max pooling, and then we are upsampling using the transpose. So for that we are defining few functions, what we have done over here, and we are using the leaky ReLU, and the optimizer is Adam, which is based upon the stochastic gradient descent. That's why we use the learning rate and all. This SWA is helping us. Sometimes what happens, we find out the weights value, but that get stuck at the local minima. That image I showed you over here, this is the local minima and this is the global minima. The loss will the loss, it will be minimum at this value, but some this is not the exact minimum value. We need to ignore this, and this is kind of fine tuning the model, so we can remove we have to find out the weight value of at this point of minima, so that we use this technique, stochastic weight averaging. Then the training part, then everything model has been built over here. Then we start the training part. After the training, this is the visualization. We can check it out as our evaluation metric is IOU, and model loss is dice loss. You can have a look, and this is the validation set, sanity check we do. Then we are comparing prediction value, prediction and target value. That's it. And threshold values, we find out the threshold values on IOU versus IOU, so that we can set the metric value where we can decide whether pneumothorax is present or not. Ultimately, once we are finding the IOU, we are trying to find out the what should be our exact threshold value, because at the loss we will set the threshold value, so that about the threshold value it will be pneumothorax will be present in the image, otherwise not. That's it.
Yeah, great. Excellent job. Surpassed my expectations, and brilliant job. There are a lot of brilliant students in this class. All of you clap hands for Gaurav. I mean, I'm like, the way you explained, I was like, so good. Explained every concept, like, for example, there was stochastic weighted averaging, learning rate scheduler also he is gone, and every metric is gone, and he has gone to the page, and he is ensured not just him, everyone who's listening the class also understands each and every concept. That is a great thing, excellent way of explaining, keep it up. Yeah, I'm like very happy with the way all the three people have presented. And who is the fourth person to go? How many people are in the class at this point of time? Who's the fourth person? Still, three people have presented. I think initially, if you're scared, it is fine. Now, three people have presented. They've explained everything. So, like, what is the hesitation? Still not confident. What happened? You're not explaining every line of code. It's only the overflow, overview of how the flow goes through and all that. This is the right time to give it a try. Otherwise, how will you know where you're lacking and where you need to improve and all? Who's the next volunteer? Kadiresan.
Yes, ma'am. I'm still not confident, ma'am. That's why.
Okay. Not a problem. What about Pravina, Purnima, Noor, Fatima? All three of you are in the class. Santosh? Santosh, you want to give it a try?
Sure, ma'am.
Yeah, go ahead. Your
I'm
screen is
sharing.
not visible
Yeah,
yet.
I'm sharing my screen.
Yeah.
Able to see my screen.
Yeah, your screen is visible. Go ahead.
Okay. Yeah, everybody is covered all the concept. Just I just go through. So these are the import we do, whatever the files we needed for to uh, run this. And yeah, here the agenda is to identify the present in the image as we see the um, uh, pneumothorax is there or not. That was the agenda. So that's what we are trying to solve as a part of this problem. And these are the imports and the files we unzip and export it to our respective folder, marks, train, and test. And that's what we do in this part of code. Then here we identify initially what we do. We create a data frame and assign 0 to all the labels, all the labels saying the thing is there. Based on the marks percentage, we assign the value. So these many set of images have the disease. That's what we do it here. Then we will circulate. We what we do is we segregate the train and validation files, and here we do the 90 and 10% uh, split. After that, what we do is we move all, actually the files are in the train and mask and also we try to segregate all the files in respective folders. That's Kera.im train and mask and I'm well and mask file. These four folders we create and we move all the files respective folders. Then, as ma'am mentioned, this data generator, which is a old method. So here they're trying to increase the number of samples as a deep learning needs a lot more images. The using the data generator part, they're increasing the sample sizes. And as you Priya mentioned, like, and even Gaurav mentioned, like many of the technique they use, blurring and changing the different the shifts the images to make the image to generate a more samples. Uh, and this is the images they trying to see the disease highlighting the red color. This is also same, and this is the IOC curve they wanted to generate. That's for the method they have written here. And this is a loss function, and so the loss function, the formula they have uses two into intersection and divided by the union of each images. And this is the model blocks they're trying to create. In the convolution block, they'll add a 2D and batch normalization, and they use the activation function as a ReLU activation function, Licky ReLU activation function, and the residual block where again they make it back to the actual image using this leaky batch normalization convolution blocks. And actually they use efficient net b4 as a base model, and they make a top layer should be false, and the remaining they will add on top of this they will add different layers as Supriya has shown the paper so that they are trying to construct here. Then they use the stochastic weight averaging to increase the better results. Then they will train the model with a different set of data generator and all. This is the training. Yeah, then the prediction goes. How and they generate the IOC curve and see the result. That's all, ma'am. Thank you.
Yeah, very good, Santosh. All of you clap hands for Santosh. And yeah, thank you for coming forward to explain it. Yeah, you can unshare your screen now. Who's the next volunteer? Hmm. Varaprasad, you want to give a tie? Varaprasad Cherukri, are you there in the class? Sabyashi Sengupta, are you there in the class?
Yes, ma'am.
Do you want to give it a try?
I mean, most of the topics are more or less covered, so I
No,
can
it's
just
okay.
go.
There are still people who are not confident. Kaziresan is not still confident. You know, they listen more number of times. See, only three people came forward. I had to call out the name of Santosh. There are still many people who are not confident. Some people will understand it 2 times. You know, some people require more number of times. They have to learn over a period of time to feel confident. So your explanation will help somebody who's still not confident.
Sure. Let me
Go ahead.
share my
Share your
screen.
screen and explain.
My screen is visible.
Yeah, your screen is visible.
Okay. So, I mean, for I think this pneumothorax, I think segmentation, I think there are two, I think, action items as part of the use case. A, to classify whether pneumothorax is present or not, and if present, what is the extent of the spread. So that's where the segmentation is going to come in. So first is the pure, I mean, classification, yes or no, and then is the spread or the prediction of how much the spread of pneumothorax is. So if you see, I mean, the standard, I think the libraries have been imported, Keras and TensorFlow and all. Then I think there are three, I think, data sets. One is the train data set, the test data set, and the mass data set. Then what I mean they are doing is they are getting the mass data set and probably doing on a high level. I mean, what I could understand is they are trying to do a standardization on the mask percentage because this is, I think, all the channels they are trying to do a summation and do that. So it will basically remove, I think, the values or the change of values from 0 down to 55 and probably have it around that uh, 0 to probably 1% and all, which helps them to label it, whether it is having that mask, yes or no. Once that's done, I mean, they are using the first, I think, train data set itself to split as a validation data set and a train data set with train and test split as 90 to 10%, which we can see the number of train and validation files. Then they are using a data generator primarily to resize these elements, as well as what, again, as per our deductions, what we saw is they are trying to use a kind of a grayscale. So what we are looking at is probably uh, this X is basically returning the images and all that, and the channels is all three channels are getting returned. And in the Y component, they are basically returning a single channel. So most likely it is sending only the grayscale image whenever we are sending the batch of say 16 images or so. So there's some augmentation also taken into consideration. I mean, this function they are not using, but whenever this function is getting called, the images are resized, and the same image with the resized image as well as the grayscale image is sent back whenever we are calling this get item function from this data generator class. This is the standard, I mean, augmentation. I mean, a couple of our colleagues already have actually told, so I'll just not spend time here. Um, then they're doing training on the or just the display of the images, what they're getting from the data generator images, where we can see all these images. Then the same images are done through that after post augmentations. So using that augmentations library, they are passing the same values, where we can see some of the images are getting distorted, zoomed, etc. So it's like these images are like zoomed and all that, just to add the augmentation values to the image. Uh, then they are doing that IOU, that is, I forgot, uh, over union, intersection, I think over
Intersection.
union. Yeah. So it's kind of a metric to find out how close our predictions are in terms of the classification and all that. So that they are defining as part of that IOU. Then there is a dice loss, which again is trying to find out the loss on the prediction that has been finally done. As Gaurav explained around the learning rate, I mean, how much, I mean, they have to probably use it for the back propagation when the neural network is running. They have now used the model blocks, one for the standard combination block and the residual block. Residual block, they are primarily using to upsample, and primarily this block is going to be used for the decoder part of the model. Then they're defining the U efficient model, which will be acting as the encoder part or downsampling the image for this entire process. I mean, there are all these blocks they have written. Uh, I think one of our colleague also mentioned the activation function. They are using a sigmoid. Post that they are running the model on the test and train and getting the model output. Stochastic average weight averaging, as I think Gaurav also put it very nicely. So they are trying to, I think, fine tune to move from the local minima to global minima as part of the gradient is concerned. Then they are looking at the training. So here they are using say 70 epochs and batch size of 16. So for every epoch, randomly 16 images are taken into consideration, where we are using, and then the same images are taken from the validation image file and the validation mask path. We are using the model.fit and getting the model, training the model here. Okay. This point, and then we are plotting the model output, our train and validation. So what we see initially, I mean, the model output and the validation functions are quite, I think, different. But as we smoothen out probably 60 to 70 epochs onwards, the data from the prediction data is more or less the same. Once that is done, what I mean, the second process that they have done is they have used the same validation data to test on the same model data. So they are using the validation data split to basically understand what is the prediction that they are getting. Post that they are using, I mean, this part, I think they are just using the validation data itself. There's a IO metric again they're defining. And here they are basically understanding the best threshold. What is the best threshold that they have to define in terms of the IOU and the threshold functions. And finally, they are using the same model to basically run it on the test model. So when the test model is found, they are again plotting it and saying that, okay, this is uh, those images which are classified as a pneumothorax is present or not present. this is another function. I mean, here in one of these images is all kind of grayed out, but I was checking in another Kaggle notebook where the segmentation was actually appearing. This current image does not show the segmentation is actually appearing, but in another notebook written by the same person, we could see the pneumothorax segmented properly. So once that is done, I think they are just using that encoded pixels on this for the exact image IDs to show whether it is present or not. If there is no pixels present, they are just putting it as -1. And this is, I think, the RLE, I think, encoded, I think, function that they are attaching to every image ID wherever they are able to find the pneumothorax. That's it.
Yeah, brilliant job, Sabyashi. I think you pointed out few things which the others have not done as well. Clarity on the problem statement itself. And there were a lot of things which you have explained really well. The way you're articulating the explanations is very, very good. I think even people who are confident, not confident earlier, should be able to understand that it was very crystal clear. All of you clap hands for Sabyashi. Good job. And so, yeah, you can unshare your screen now. So, how confident are you, Kadiresan? Are you still not? Kadiresan is in the call. How confident are you?
Yeah.
Are you still not confident, or what is it? What is it you're stopping you from understanding? Is there any bottlenecks or something like that? If you say we can work on it.
No, ma'am. There are some specific points I want to like dive deep to understand, like this. For example, this stochastic weight average, dice loss. Those things are something that I want to understand in detail.
That stochastic
Apart
weight
from that,
averaging and
yeah.
all is only done to improve the score and all. That is something additional. The basic pipeline, if you understand, that's see the stochastic weighted averaging may work for this use case, may not work for the other segmentation use case. It's use case to use case. There are specific tricks you might have to try, to make increase, because Kaggle is all about increasing the best leaderboard score, right? So there are several tips and tricks which might, but the basic pipeline, if you are given an image segmentation problem, the basic pipeline is what you should be very thorough with. That you're confident outside the stochastic weighted averaging and all. The
Yes,
basic
ma'am.
flow, you're confident.
Yeah. Those things I understood.
Okay. See, next, the people who have explained now, we'll have a revision on the last day. Your final evaluation will be the image classification only. I'll be giving the, I'll share 2 use cases beforehand, because I don't think 3 hours is sufficient to put an end-to-end notebook and all. It's not possible. The main objective of conducting evaluation and all is to, ensure you are doing good with things, right? So I'll share beforehand some 2 use cases, out of which 1 use case will be for your final evaluation. So that I'll share 1 week before itself. Next week, I'll be sharing what is exactly 2 use case which you will be having it for evaluation. So you have almost 1 week's time till the evaluation. So the way you will be doing it is, I'll be sharing a folder where you will be uploading the notebook. So you have to see all the source codes are there. If it's a Kaggle competition, you have more than 500, 600 notebooks already. So there is nothing you have to write it from the scratch. So you can take, you can use as many as reference materials. You can do an end-to-end notebook. You will download the notebook from Kaggle, and the notebook has to run without errors, and you will be uploading. So techniques and all you can copy from several Kaggle notebooks, combine 3-4 Kaggle. You have 1 week's time. So for both use cases, you can combine multiple Kaggle notebook techniques, do whatever, cut, copy, paste, whatever it is, but understand the end-to-end flow. And you will take a video and you will explain your own code and make that submission. That will be your evaluation, because Kaggle competitions means 600, 700 notebooks are already there. So cut, copy, paste anybody can do, but how will I know that you really understood what you wrote the code? That you will make a video of 15 to 20 minutes recording the entire notebook pipeline which you said, and you will submit. So here the scoring will be what is the innovative technique. See, image classification is a simple thing. So if you take this numerics segmentation, he has tried different techniques, right? He has tried stochastic weighted averaging. There are several tricks and tips he has tried. So you have 600 to 500 notebooks at your disposal. You can take the highest scoring notebooks or highest winning solutions. So a competition which has got over. You can take the winning solutions. You can take the highest scoring notebooks or the most voted notebooks and all these things. You can combine lot of tips and tricks, and how many tips and tricks you are able to include in your notebook, how you're able to present it is what will give you the highest score. And your ability to articulate the concepts clearly is what will differentiate. That will be your evaluation. So the questions will be shared before that. So you will have a week's time to prepare for both the things, out of which one is what you will be submitting for your final evaluation out of the two competitions. So the competition evaluation will be an image classification problem, which is going to be the easiest of all. Compared to segmentation, object detection, image classification is the easiest of all. And you have a week's time to prepare, go through all the, you have 500 notebooks at your disposal, out of which at least 50, 60 will be great notebooks. You can go through, copy. You're not going to write every line of code from scratch. You can copy the block of code from Kaggle, put it in your notebook, run it. So that is what you will be doing it. So next week we will be revising. We have still not completed the ultrasound nerve segmentation. One of the use cases is pending. So we will be revising object detection, image segmentation, and image classification once again thoroughly. We will be covering some of the use cases of image classification once again, and we will be explaining the code. So next week will be a lot of revision. Revision is what is the next week's agenda. So whatever use case we have covered, around 10 real life use cases. If you are very thorough in these real life use cases, you can crack any problem. So learning too much is not, it will not work. Whatever you learn, how strong are you in that? See, image segmentation and all has got lots and lots of use cases. If you're just very strong in image segmentation, you can crack multiple use cases, publish multiple papers. That's a lot of scope you have, both in healthcare, both in AI for social good. You have multiple use cases. So be strong in whatever you learned. So next week we'll be covering one of the use case which we are supposed to cover that in the afternoon. But since you took a lot of time for learning the first use case, we'll be covering the ultrasound nerve segmentation next week, and we'll be covering once again revising object detection and image classification. Next week I'll be sharing the two competitions which will be your final evaluation component. You have all the notebooks at your disposal to prepare an end-to-end notebook. All the tips and how much of tips and tricks, how much of additional techniques you add to the notebook pipeline will what determine your scope and the way you articulate and explain your notebook. So anybody can copy paste and put a notebook, working notebook, but then while you're articulating, I'll understand how much you understood. So how you articulate and all that. A recorded video 15-20 minutes will be there. One notebook and recorded video of that notebook is your final evaluation component. And this is it for the computer vision. So yeah, we have done for the day. And I'm happy like at least 5 people came forward and explained the end-to-end flow. You're slowly able to answer, grasp a lot of code. That's a lot of code you've got up in a very short period of time. How many people are there in the class right now? Can you raise your hands? So yeah. Varaprasad, can you unmute yourself? Varaprasad Cherkuri. Are you there in the class?
Yes, madam. Yes, madam. I am there. I am able to reach up to half of the notebook, madam. That's why I am not today content. That's why not approached.
So next week you will be explaining image classification, object detection. So you have a week's time to prepare. So go through the codes
Yes.
and be ready. Yeah.
Same
okay.
notebook. So same
No,
notebook, madam.
Will be ultrasound nerve segmentation. One more use case is there.
Okay, madam. I will follow that one.
By next week you have to be up and running with all the codes. You should be able to follow.
Okay, madam.
Vinaya James, can you unmute yourself? So like, how are you? How confident are you? Can you comment on that?
I'm not that confident. But
So what
yeah.
is the bottleneck here? What is stopping you from becoming very confident?
No, actually, I was like, I was trying to read the code, but I don't know that how to explain it actually.
But you understood it?
Yeah, I understood it.
Okay, your final evaluation will be explaining the code, writing the code and explaining it as well. So before your
I'm
final
very
evaluation,
bad in explaining, but I'll try.
yeah, you can explain it your own way, not an issue. And so you have to, work hard this week to understand a lot of code. Practice will make you good. So there's a lot
Yeah,
to
ma'am, I'll
work.
try.
Yeah, okay. So, Sri Hari, can you unmute yourself?
Yeah, hello, ma'am.
Yeah, how good are you? What is bottleneck? How confident are you and all?
Actually, because of a problem, I'm only on mobile, so I could only follow the explanation. So I could not try today. I will revisit the videos and I will try to recreate the notebook. If I get doubts, I will call you, ma'am. I'll message you.
Okay, good. So you're able to follow the codes which is being discussed so far, or you're have not having trouble understanding, or what is it?
No, so far it's good. I could follow today.
Okay. Next week you will be doing an explanation for one of the notebooks. Be ready. Pravina, can you unmute yourself?
Yes, ma'am. I was
Yeah.
able to follow the notebook, but I need more practice. I feel to be more confident. I'll do it next week.
So next week you will be doing a notebook walkthrough. So
Yeah.
one of the use cases. So be prepared. Either it's can be image classification or object detection. So by
Okay.
next week, there's a lot of hard work which you need to do from your end. Yeah. Vandana.
Hey, Usha, that is not my surname. This is Gopi, by the way.
Okay. Yeah, Gopi. Yeah, please tell me.
Hey, actually, today I logged in from my office laptop. Probably I couldn't able to share the screen confidentially. So next week I could able to make it out because of my personal laptop.
Okay. So how confident are you with regards to code? Are you able to follow? Or if you're not confident, what is the bottleneck? Can you share that?
Uh, in fact, bottleneck is not the situation, but I could able to follow the code when you are delivering the class in the lecture. I'm good with that, and I could able to follow all the teams whoever has been discussing the same code in the different aspects.
Okay. So next week you will be able to share your screen and do an explanation of one notebook. Either image classification or object detection, you will be asked to explain. Or you will be up for it. It will be all
Yes,
flow only.
yes, I do.
Okay, good. So, people who are there in the class, the people who have been take Kadiresan, you should also work hard from your end. Next week, you will be presenting. And so people who are in the class, we have all discussed. If there is any bottleneck, you can let us know. So next week is for revision so that you do your final evaluation really well. There are a lot of concepts in computer vision out there, so I can cover those concepts as well. But my concern is whatever you have learned, if you're thorough in that, that's more than enough. So, especially in data science, it's not about learning too much. It's about how strong you are in what you know. Little if you know also. If you're very strong, that is where you can earn a lot of money. So there are a lot of people who specialize only in NLP, but they're extremely talented. Skip, they are the go-to persons in knowledge graphs. They are the go-to person. Only knowledge graphs they know. Outside knowledge graph, they don't know anything. But they're the subject matter expert in that. They're so strong that even in sleep, they will debug. And those people earn around $200 per hour, $200 per hour. That's strong only. Outside that, they don't know any computer vision, anything. So one thing, if you know also, you are very strong in it, then you will be most in demand in the market. Not about learning too many things and not knowing anything properly. That is waste. If you know one thing also, you should know very strong in that. And So that is why whatever you learn, image classification, object detection, and segmentation, if you're very, very strong in it, that's more than enough. Segmentation itself has so many use cases. You can try a lot, a lot, a lot. So this is what we will be revising on the fourth day. There are a lot of other concepts which we can do also, but there are a lot of people who are still not confident. Teaching too much is waste, in my opinion. Like, whatever has been taught so far, you should be strong in that. And we'll also be prepping for your final evaluation part also. So you have a lot of time. I've already told you what is your evaluation going to be and all. So you have a lot of time to prepare yourself. So be up and strong with coding. So with this, we'll wind up today's sessions. If anyone wants to say anything, you can go ahead say. If there is nothing you want to say, then we can wind up the session. Does anyone want to say anything?
Ma'am, I have a question. I mean, you already told that, but just wanted to know how to pick the best notebook for a competition.
You can actually choose the best notebook by filtering by best score.
Score. Okay,
Best
thanks.
score, best score.
Ma'am, one thing. Are we going to cover that anomaly detection in next class?
Which one?
That anomaly detection in images.
Anomaly detection in images. You can share that in the WhatsApp group. You can share your problem statement. I'll go through it and I'll point you out to the right resources for dealing with anomaly detection in images. I'll point you out to the right resources so that you can get started up and running on your own. But I won't be covering it because that even if at all I want to cover new concepts, then I'll only be covering GANs because that is
Okay.
a major area. I wanted to cover that, but the thing is, I don't want to teach too much, and all of you flunking your evaluation part is not my agenda. My agenda list, whatever you have learned, if you, I just want to keep it revision so that that image classification part, all of you are very strong, so that you clear your exams. So GANs was my initial plan to teach on the final day, but that I'm not going to teach. I'm going to there are ultra nerve segmentation example I will cover, and then object detection, some real world use case, image classification, real world use case, but we'll be like revising it thoroughly with many people explaining, sharing the screen and explaining so that all of you have understood 100% like that confirmation I'll get. Then I'll share the use cases for your final evaluation, and I'll also go through one or two notebooks each for each use case on the final evaluation, and then with that we'll wind up. That is the agenda for the last day. But for your specific use case, if you can either WhatsApp me personally, or if you want to put in group or something like that, if it is something like that, then because even anomaly detection in images is not a prime use case. There are people doing it, but then it is not like the main divisions like segmentation, GANs, or object detection. It's not like the main part. So for that part, I will guide you by sharing you and to the right resources and helping you up and start it. I'll personally guide you.
Okay. Ma'am, OCR is also part of image analytics, right?
OCR is also part of image analytics. So OCR involves object detection, right? So you are basically for even if you have to, take a helmet or not helmet detection. What is that? If you have to take an object and if you want, okay, if you're driving a
Actually, actually OCR, I'm talking in terms of text from the scanned images.
Yeah, you can use some existing packages. I think this
Yes.
OpenCV and there are many libraries, Tesseract and all these libraries will have APIs to get that job done. OCR, but that may not still be efficient because for Indian roads we tried Tesseract and all, it still didn't work. So you might have to do further, image enhancement and then apply. You have to increase the resolution of images and then apply Tesseract and things like that. So then you might get a better. There's some of the image enhancing techniques which you might have to work on to increase to get better results for at least OCR. If you're doing for Indian road conditions, it definitely doesn't work. And
So,
so
so are
OCR
there,
will not be covering OCR. So
okay,
my plan was to cover image classification, object detection, image segmentation, and GANs. If at all
okay,
I want to cover, then I'll be covering GANs only. It might be in your earlier syllabus, it might have been there. But earlier, some other instructor was supposed to take the class. So maybe in his agenda, he might have kept OCR and all that. See, image computer vision is very huge. You cannot cover every concept in computer vision. It's not possible in 4 days. You require at least 2 months of full time to cover most of the concept. 80% of the concept to cover. You have to sit 5 days a week. 80% of the computer vision we can cover that way. If you sit for 2 months, it's huge. We cannot cover everything. I'm just covering which has got the majority of use cases. If you take, according to me, image segmentation has got the highest number of use cases. The many use cases are there in image classification. Object detection has got a lot of use cases, and GANs has got a lot of application. These are like major ones which has got like which covers around 60 to 70% of the real world application falls under these four categories. So that's why I targeted it. But I can guide you on OCR. Maybe I can guide you for next week. I can guide you like what are the best resources. Maybe I can show some sample code and I can quickly walk you through that. That way I can help, but I may not be able to take that up and cover it. Teaching too much may not work. That's why I want. But if you personally want to understand, then I can help you out with it.
That would
Yeah,
be helpful, Usha, because there are, if you look at corporate, they're not doing too much image classification as we are doing, but they're doing a lot of document reading, right? Automatically reading invoice, checks, etc.
Yeah.
So OCR
No,
is sort of relevant from that
I think,
perspective.
no, they are doing a lot of. See, it depends on the startup which you are working. So you have a limited knowledge on few of the startups, and what they are doing is not the entire world which they are doing. There are a lot of use cases of image segmentation in healthcare. Many startups are doing. Have you heard of Sigtubal? There are a lot of use cases like million who are about to become unicorns. That Niramai. Niramai is a breast cancer classification startup. She has won like the world's best award. She's a women startup founder. She from Bangalore. She is one of lot of startup founders. I think you're not aware of the computer vision startups which are doing segmentation and image classification. There are startups which do this and there are startups which do this. There are many startups which do such works. There are so many startups which deal with geolocation, satellite imagery segmentation, and you must have heard Locus is doing that. There's one more startup as well who are doing a lot with satellite imagery, giving location based. Inflytech is another computer vision startup which does a lot of work with object detection. Walmart, all the e-commerce websites like Amazon, Walmart, all do a lot of segmentation, classification, object detection use cases. So many companies with so many use cases under these GANs is also, the GANs is an important topic because GANs is used in addition with image classification, segmentation, and GANs is used because so to enhance your images or a lot of things, to create a synthetic data or to create certain things, it might be an image classification problem statement, but you will also be using GANs as a part of your pre-processing or post-processing. So GANs will come under all three categories. It will come. So GANs is a very important topic in my perspective. So I don't think I don't agree that a lot of companies are not doing is not a right statement according to me. In my perspective of analyzing startups, there's so many startups who specialize in these areas and almost are going to become unicorn. So there are a lot of job opportunities also in these areas. Image analytics and text analytics, there are a lot of people, there are a lot of third party vendors who are expert in this. A lot of companies who may not sit and write code from the scratch. They may use APIs or vendors for doing OCR and things like that. There are very few startups who might sit and build an OCR system from the scratch and things like that. I think there are equal opportunities for both types of use cases.
yeah, actually, ma'am, I'm interested in Tesseract because I feel that Tesseract is the bottleneck for the OCR. And are there ways to improve the performance of Tesseract?
See, I can guide you for the OCR and all. I can guide you with the right kind of resources. I can guide you because I'm also, one thing is, in my perspective, what is the best I'm covering, and the second thing is my area of specialization I'm covering. So OCR is definitely not my area of specialization. So I don't want to cover things which is not my area of specialization. So but I can guide you and I can take
Yes.
20 to 30 minutes of class. I can cover, but I may not go depth like these use cases. I may not go that depth.
Ma'am, one
Oh,
guidance we need. which is specifically for building the custom model. So in some of the notebooks we observed, people have built the model layer by layer. So that is one area I'm not very confident about. I
Yeah,
know.
we'll definitely revise the custom models once again. And I'll also share a list of startups who work in image segmentation and object detection and image classification in India. So if you want to and GANs who are just specializing in this in healthcare, and they're making like they're almost going to become unicorns. There are many startups like that. I'm not, if you're not aware of it, I'll give you one big list of some 20-30 companies. You can seek out for internships. I'm not sure if they'll give you a full-time job,
Sure, ma'am.
but you can seek out for internship, unpaid internship. You already have a full-time job, right? You can let them know that you'll work for 2 hours, 3 hours as an unpaid to get just an experience like that. You can reach out. They may not. I'm not sure if they'll agree for a full-time employee, and if they will compensate the exact pay which you demand. That I don't know. But depends if you have a referral and things like that. But I can share you a list of startups which you can seek out for who specialize in these areas. The hottest startups are the geolocation based startups, especially dealing with satellite imagery, agriculture and all. Satellite image, see a lot of startups. One startup, Cropin. How many people have heard of the startup Cropin? Cropin. It's one. It's going to become a unicorn. Cropin, agriculture based startup based out of Bangalore. It's making a huge waves. It's like one of the biggest startup which does a lot of computer vision based techniques on agriculture. It has won lots and lots of awards. So there are many startups like this which are using these days. The many startups which are using agriculture, a lot of computer vision is used, especially object detection, image segmentation, and classification. These are use cases which are used quite a lot in Indian agriculture, and many startups exist in this space. So I'll give you first a list of startups which exist in this place so that you can reach out to them for job opportunities and collaborate with them. If they are not agreeing for paid internship or full-time paid job, then you can at least to get some internship, you can collaborate with them. If they refuse, then don't worry, create your own internship, find your own use cases, form a team and solve the problem. Put a portfolio of projects so that anybody can hire you. As long as you have strong skills, if you are the number one expert in knowledge graphs or the number one expert in thing, you don't require another company to hire you. You can earn a lot of money by just consulting. Consultants earn a lot of money more than the top companies. I know a lot of my friends making double the pay as consultants or 3 times the pay of what Google India pays. 3 times the pay of this consulting is hot in the AI space. So if a company you should try, because rejections is a lot. There are a lot of rejections in AI startups and AI full-time companies, especially if you're transitioning from a full-time software engineer to AI space. There are lots of rejections. I have seen known people 30-40 companies they attended interviews, rejected, and finally they went into some big company and all. They landed up. There were cases like that. Rejections is quite common, so you shouldn't give up after trying for a few times. But in spite of that, also if it's not working, then specialize in one field and be very strong in it. Put great build, develop a website, put all your great portfolio of unique projects. That's more than enough. And market yourself really well in LinkedIn and social media. Be quite active marketing your startups and all that, projects and all that. That also you can earn a lot as a consultant. There's a lot of demand for consulting and AI at the moment. So instead of like dabbling and touching your hand in multiple things, whatever you learn, be very strong in it and be the number one expert in it. That should be your goal, because nobody wants somebody who's dabbling in multiple things and don't know even one thing really well. That is not something which people look for when you're hiring. So that is why. So I will cover 30 minutes of text analytics OCR. I'll also cover anomaly detection in images for another 30 minutes I'll cover. And if there are any other topic like this, small topics you want to cover for short time, then I can cover that. But it will be majorly the revision on the final day. But I can touch base on these kind of topics. I can touch base on it. If there is any, you can let me know now so that I can touch base on those topics. So outside that, any other people want to cover any other topics?
In fact, we don't want to say this, but the OCR is one of the important thing as a professionals that we are associated with the clients or the customers in the different companies that which we are working today. OCR is playing one of the critical role for us. So an intuition and the guidance to that level can help all of us, because we end up the day being still not completely transformed, most of the guys in the team, to the data science or artificial AI engineers. So OCR should play one certain role in our career, at least for the transformation, apart from what you have reiterated in the class today.
I'll cover 30 minutes of it, but I can't cover 1 day of OCR. That I won't be able to do. I'll cover 30 minutes to 45 minutes and guide you with the right resources.
Okay.
OCR is not my area of specialization, so I can't take 1 day of OCR. I can definitely not do that. But I can guide you with the right resources, and 30 to 40 minutes I can cover on that topic. That much I can do. So I can only take, I'm not an expert in everything in AI. I'm an experienced professional, but I'm not an expert in everything. So whatever projects I have worked on is what I have a greater experience on it. And only if I teach those things, I'll be able to give you a better insight and guide you better. So I do a lot of work in the NLP space as well, a lot of work in the computer vision as well, but predominantly in these areas: image classification, object detection, segmentation, GANs. So these are topics which OCR I've used, I think, only for that Kolkata police thing. You know, I showed you the demo, right? That's the only use case where we have used a bit of OCR. But otherwise, I don't think I've used. So you can, or maybe have that as a separate class, or you can request for a special class where there's some expert who has done a lot of work in that might come and teach you. That might be the most appropriate thing. So I can touch base on 30 minutes to 40 minutes. If it is that important for you, then you should require request for a 1 day of OCR class, and you should get the right person who's expert specializes in that to teach you. So is there any other topic? There is a lot. Video analytics is the top field. We have not. Video analytics is very a bit of a tough, but video analytics is hot in the market. A lot of people want to do video analytics and self-driving cars, and these are all like hottest topics in the thing. There are a lot. Video transformers is recently released, SOTA architecture. So you have a lot with video analytics which you can do. So those are topics which you guide you, like what all you can study in videos, and you can explore it on your own. Like I'll share the list of resources and you can explore it on your own. That is what will be the agenda. So roughly on, so from whatever you have all said, I'll be covering like 20 to 30 minutes on that anomaly detection in images, and OCR maybe another 30 to 40 minutes. And then the remaining part will be the revision. We have not covered the use case ultrasound nerve segmentation, and we've not covered, we'll be covering a bit of image classification and object detection once again. And be very thorough with it, and I'll introduce you to your evaluation problem statements, and that's how we'll do it. By the way, if you just know OCR, you won't be able to transform it to data science and all. I don't think, I'm just hearing it for the first time, like somebody telling me, OCR will help me transform into data science career. Maybe within your organization, if they are doing a lot of OCR and if you become an expert in it, maybe you can transition. So that way it is okay. But I'm not sure. I've not heard anything like that. And it's not that messy. There are few skills which will stand out. For example, knowledge graph is hottest in the market. So knowledge graph is like a lot of companies use knowledge graph. So if you're very strong in graph, just one thing, if you're very, very strong, you don't have to know anything. You'll get a lot of jobs. That is like Mbibe. Have you heard of companies like Mbibe? Mbibe is bought by Reliance Jio. They use some of the biggest and most complex knowledge graphs. Most every company you name it, they use knowledge graphs for recommendation systems, graph neural networks, knowledge graphs. These are like very important topics in NLP. And if you just know this and you are very, very strong in it, there's a higher probability of getting hired. But OCR is not that kind of very important topic and all in my opinion, because I hire a lot of people. There are a lot of people who work under me, and I'm into the hiring space, and I also know a lot of good idea about the startups and what kind of work they do. It's a good skill to have, but just knowing that one skill will not put you up in any job transformation and all. It's a good skill to have, and it's not that complex and all. I think you can pull it off easily with little bit of guidance and things like that.
And one thing. Hello.
Yeah, please go ahead.
Ma'am, in anomaly detection, there are two things. One is outlier detection, and another thing is novelty detection. So I am having few doubts in novelty detection. So please consider those 2 points also while.
Sure. The anomaly detection itself, I want a description of the use case from you. You can WhatsApp me personally about the use case description. And whatever you want to cover on that day, final day, you please share it. So if anybody outside this anomaly detection and OCR, if you want any other topics to be covered, that is, we won't have time to cover a single topic the whole day because it's the last day, right? So there might be small topics like this where you want some touch basing, and also for these topics, what I'll do is I'll tell you what that is. I'll take 2-3 codes and I'll walk you through the codes, how it is done, what are the various architectures out there, how it is being done, and all that. So there will be some kind of a code walkthrough for all these concepts. So if there are anything else which you want outside these two concepts, you can always reach out to me and let me know before Monday evening, because I have a packed schedule, so I won't have sufficient time. I have a lot of conferences coming up next week, so I may not have the bandwidth. If you tell me for a Saturday class, if you ping me on Friday, and if you tell these concepts you cover tomorrow, then I won't be able to do it. You have to let me know by Monday, not less than Monday. So you have a couple of days time to find out the concepts outside these two concepts. If you have, then you can let me know by Monday. Those concepts also, I'll walk you through 1 or 2 code examples based on the complexity. I'll walk through. If it's something like OCR, then maybe 2-3 code examples. I'll explain, give you the intuitions, and after that, what are the resources you can get started, what can be the learning path, that much I'll cover. But if there are any other topics you want to cover in computer vision, I can touch base on it. But let me know by Monday at the earliest. Beyond Monday, if you let me know, I won't be able to do it because I need to prepare what kind of resources to present and all that, right? So you'll have to let me know by Monday so I can prepare. So if there are any other questions, you can let me know, or we can wind up for the day.
Thank you.
Thank you, ma'am.
Yeah, thank you. We'll wind up for the day. Catch you all next week. Yeah, take care. Bye-bye.
Thank you.
Yeah. Thank you, ma'am.
Thank you, madam.